Welcome back. In this video, we're going to cover the following. But before that, to be able to solve this problem, you need to know Calc 1 and Calc 2 at least. I'm going to skip some proofs that I'm going to assume easy, and I will go through all the steps for the others, okay? So here we are given that x is positive and f0 of x is 1 over x. Okay, we can define f of n of x as the nth derivative of 1 over x. And we define a series by g of x is the sum from 0 to infinity of 1 over fn of x. We want to compute g of 1. So here, to find a formula for g of x and to be able to evaluate, I think the easiest way is to find f of n of x. Okay, that means we need to find a formula for the nth derivative of 1 over x. Okay, and remember that we have the derivative of f over g. So here it's f prime times g minus g prime times f over g squared. We assume that g squared is not 0, or g of x is not 0. Okay, but here, since we have only one, when we want to find the derivatives, okay, we're going to treat f here in this formula as 1, and therefore we can have 1 over g, the derivative, as minus g prime over g squared of x. Okay, so this is a quick formula that would let us find the derivatives of 1 over x. Here, f of x now, in our example, is called f of x 1 over x. So this is the 0th derivative. Okay, we didn't do anything to it. If we want to find f prime, the first derivative, we're going to find it from here. So here, our g in this case is x. Okay, so here, this is my x, this is 1 here in the formula. So I can do minus 1 because g prime of x is 1 over x squared. Okay, if I do the second derivative, this is f1. So this is the notation used, f1. f2 is the second derivative of this first derivative. So that means to find it, I need to keep this one minus 1, and the derivative of x squared, which is minus 2x over x to the power 4, this gives me 2x, or 2x over x to the power 4, or 2 over x to the power 3. Okay, if I keep doing it, I'm gonna get f3 is minus 2, the derivative of x3 is 3x squared over x to the power 6. I can do minus 2 times 3 over x to the power 4. Okay, and this is f3 of x. f4 of x is the fourth derivative of our function, but it is just the first derivative of f3. So I have minus 2, so f4 minus 2 times 3 times the derivative of x4, so it's 4x3 over x to the power 8. So this gives me minus 2 times 3 times 4 over x to the power 5. And therefore, I can find a relationship between this n and the derivative in general. So here, this is 4. So here, x to the power 4 plus 1. And this is just minus 1 times 2 times 3 times 4, which is the factorial. So I can assume that my fn of x will be minus 1 to the power n times n factorial over x to the power n plus 1. Okay, just by looking at this one here and differentiating the f, which is 1 over x. Okay, so let's see if this is true. So when n is 0, should I get my original function, which is this one here? So if that's true, so minus 1 to the power 0 is 1, and 0 factorial is 1 over x to the power 0 plus 1, which is, this is 1 over x. For n equals 1, I'm going to have minus 1 to the power 1. 1 factorial is 1 over x, 1 plus 1, which is 2. So I have minus 1 over x squared. So I have this one here. This is true. So I can use induction. Okay? So now I can use induction and prove that this is the true formula that I need here. Okay? So this is the true formula. Fn of x is minus 1 to the power n times n factorial over x to the power n plus 1. Use induction to prove this result. Now I'm going to use it here. So therefore, my g of x will be the sum n going from 0 to infinity of 1 over fn of x. This will give me the sum n going from 0 to infinity of this one here. So when I'm going to flip, I'm going to get x to the power n plus 1 over n factorial, and minus 1 is going to be itself, because minus 1 to the power n is itself when you flip it. Okay, so now I have my g here. Okay, and I can see here that I can polish this one a bit. Okay, so I have here something that I can something that I can do. Okay, but I need to get 1 here. So here I can split x to the power n plus 1 as x times x to the power n. So I take x outside. I'm going to have x times n going from 0 to infinity minus 1 to the power n x to the power n over n factorial. And I think I know this one from series. Okay, so I know that e to the power x can be expressed as x to the power k or x to the power n over n factorial, and going from 0 to infinity. Okay, the only thing that I don't have here is that if I switch x to some minus y, I will have e of a minus y is gonna be n going from 0 to infinity of minus 1 to the power n y to the power n over n factorial. And from here I can see that this is just x times e to minus x. Okay, and therefore my g of x is just x e to minus x. Okay, so now I can evaluate g of 1 by plugging just 1. I have 1 e to minus 1, which is 1 over e. Okay, so this is the solution for this problem. This is the Berkley math competition from I think 2023, I believe, and this is the solution. I have skipped many of the steps, but this is clear for those of you who have taken Calc 2 or 3. Okay, so I think that's it. Thank you very much.